everybody, today we're going to be reviewing our science unit on matter, specifically looking at the different states of matter, which are solids, liquids, and gases. What is matter? Matter is anything that has mass and takes up space. We use mass to measure the amount of matter, and we use volume to measure how much space an object takes up. Basically, everything is made up of matter. The steam coming off the pot, a glass lemonade, or a soccer ball are all considered matter because they all have mass and take up space. There are three states of matter: solid, liquid, and gas. The difference between each of these states is the way the molecules move in the piece of matter. In a solid, you'll see with the red dots, all the molecules are packed tight together. They're not moving and they are forming one shape. In a liquid, things start to get a little bit more fluid and they start to move around a little bit. And in a gas, the green molecules are bouncing everywhere and they're moving around quickly. The first state of matter is solids. Solids have definite shape and volume. Like we saw on the slide previously, solids are molecules are tight packed together. This is why they have a definite shape and volume. They're not changing. Take a look at these pencils placed in this container. The pencils hold their shape as they're placed in the container, and they don't grow and shrink depending on where they're put. They have their own shape and own volume, and it doesn't matter if I was to pick up one of those colored pencils and put them in a different container, it would still look the same. Unlike the solid pencils, liquids have a definite volume, but will take the shape of their container. Think about the difference in molecules. Solid molecules are packed tight together, whereas liquid molecules start to kind of move around, allowing them to take the shape of their container. Looking at the pitcher of water being poured into the glass, the water is not controlling the shape it's taking. Instead, it's going to fill the glass depending on its shape. Gases have no fixed shape or volume. They will fill the entire container. Remember, gas molecules are bouncing around everywhere and going in all different directions, the complete opposite of the tight packed solid molecules. Think about a balloon. If I was to blow air into the balloon, I'm blowing gas. However, have you ever popped a balloon? Right? As I'm blowing it, the balloon's going to continue to grow, and it's going to continue to keep trying to fill that entire container. There's never going to be a lack of gas, right? I can continue to blow air into the balloon, but eventually the balloon will pop because it can no longer hold the amount of gas. Matter does not stay in one state. It can change states by taking away or adding heat. It's easiest to think about this when talking about water because water can easily change between all three states. Water in its solid form is ice. Once you start to add some heat, the ice is going to start to melt, turning it into a liquid. Continue to add more heat and it's going to become a gas, turning into water vapor. However, going the opposite way, if we begin to take away that heat, the water vapor is going to become water droplets, turning back into a liquid. Again, if we begin to take away even more heat, the liquid is slowly going to reform back into ice. Water can fluidly move from all three states of matter. Now that we know that matter can change between all three states by adding or taking away heat, and we know that water is one type of matter that can easily move between all the states, I want to challenge you all to a question. The question I want to research is, how can I make ice melt the fastest? How can I get it changed from a solid to a liquid? If you want to follow along with me in this experiment, here's what you're going to need. 3 plates, 3 ice cubes, salt, water, and a timer. What we're going to be doing is we're going to be placing 3 ice cubes each on their own plate. 1 ice cube will be left completely alone. 1 ice cube will be sitting in room temperature water, and 1 ice cube will have salt on top of it. You can also add 1 more plate and 1 more ice cube, and add some sugar. I was out of sugar at the time I was doing this experiment, so I chose to skip it. Before we start our experiment and start our setup, I want you to grab a piece of paper and take a moment to think. What do you think will happen? We need to create our hypothesis. Which ice cube do you think will melt the fastest? Do you think the ice cube in the room temperature water will, because the water will help it become more water? Will it be the ice cube in the salt because it will break down the ice cube? Or will it melt the fastest just left alone? Take a moment and think about what you think is going to happen before we move on and start the experiment. Now it's time for our procedure and our experiment. I'm going to have you guys set it up with me. I'm going to show you how I set it up my chart to help me track my data as I time my ice cubes, and how I set up the ice cubes. Alright, so we are going to begin to set up so we can help record during our experiment. So at the top of my paper, I wrote my question, which is what ice will melt the fastest? My hypothesis, you want to make sure you start out with a sentence frame, I think, and you want to choose whatever you think may happen. There's no right or wrong answer to a hypothesis. We are doing the experiment to prove it wrong. So I'm going to say, I think the ice with the salt will melt the fastest. And I want to make sure that I'm now adding after I've said what I think, because I want to give a reasoning. So I'm going to say because the ice will break down, the salt will break down the ice. So I think the ice with the salt will melt the fastest because the salt will break down the ice. I don't know if that's true or not. That's why I'm doing my experiment, to figure it out. And so the next thing we want to make sure is we're going to make a chart so we can track as we're timing the ice melting. So you just want to draw a big rectangle. And then I'm going to split that into threes. So lengthwise, I'm going to do sections of 3. And then I'm going to draw one line here. And I'm going to write ice. I'm just going to put plain. That's our ice that's going to have nothing. Then I'm going to put ice with salt. And then ice in water. I'm also going to draw more of like a dotted line going down here, because I'm going to use this big box for my observations. And then this is going to be my final time. So as my ices are melting, I can stop every few seconds and kind of jot down what I'm noticing. And then right here, I'm going to write the final time of when each ice completely melted to water. The last thing you want to add to your paper is your conclusion. Your conclusion. So right here at the bottom, once I'm done with my experiment, I'll be able to state whether my hypothesis came true or whether it didn't. All right, now I'm going to show you how to set it up. All right, now we're going to set up our experiment. So I have 3 of the same bowls because we want to keep that constant, because the only thing we're changing is what we're putting the ice in. So I'm going to grab 3 ice cubes from the freezer. I've kept them in the freezer this entire time so that they're all going to start at the same time. I also need my phone because I'm going to be using the timer on my phone to watch each ice cube. So I have my salt shaker that I'm going to shake some salt onto one. I have room temperature water. This is water that I poured a few minutes ago and I've let sit out so it's not as cold coming out of the faucet. And then I have just my regular ice cube. So I'm going to place one ice cube in each container. For the salt, I'm just going to shake some salt on it. For the water, I'm not going to pour all this water, just enough that it's sitting in the water. And then I have my plain ice cube. The last thing I need to do is I need to now set my timer. And I'm going to begin observing. And what I'm looking for is which one is going to be completely changed from a solid to a liquid at the end. I'm not going to show you the experiment because I want you to figure it out for yourself, but make sure that you're using your chart, checking it in, and then I would love to see your final work on Flipgrid. At the bottom of your paper, you left room for a conclusion. In your conclusion, I want you to be thinking about some of these questions. What happened? Was your hypothesis correct? What surprised you? And what was the results? Which ice cube took the fastest? Which one took the longest? I would love for you to either take a picture of your conclusion and post it on Flipgrid, or you can just take a video of yourself explaining these different questions and your reactions to the experiment. The Flipgrid code will be listed in the choice board.